So in this case, this is going to be intermolecular forces, or part 3. We're going to make comparisons among two molecules, and we're going to decide which one has a greater intermolecular force. For these cases right here, we have to draw the Lewis structure, so be aware of that. Let's look at carbon dioxide, or OCS. So I ran out the Lewis structure. Remember, carbon dioxide is nonpolar. We discussed it in a previous video. OCS, if I drew a Lewis structure of it, it's going to be polar. Again, polar is going to have strong intermolecular forces. In this case right here, I have dipole forces. Nonpolar only has LDF. So the OCS has a stronger intermolecular force. So again, if it's polar, it's going to have stronger intermolecular forces than nonpolar. Ionic has the strongest of them all. I'll look at number 2. This one is SiO2. So selenium dioxide or sulfur dioxide. So their Lewis structure are both similar, and they're both polar. Now, what's going to break the tie is, if I look at your periodic table, selenium is below sulfur. Selenium is bigger. It has a higher molar mass. So selenium is what they say more more polarizable. So if they're both the same, say both polar, they're both nonpolar, whatever the case may be, go by the size. Selenium is bigger than sulfur. Has a greater molar mass. The electrons can shift around a bit easier because it's a bigger electron cloud. So in this case, the selenium one, that has the strongest intermolecular forces. They're both dipole, don't get me wrong. So if they're both dipole, or they're both nonpolar, or the case may be, go by the size. The bigger one is going to be the one with the stronger intermolecular force. If we look at this one, this is actually ethane, and this is actually formaldehyde. I drew them out. So carbon-hydrogen bonds, if it's only in there, it's going to be nonpolar. This is polar, so this is going to have the stronger intermolecular force, and this one has dipole-dipole. And this one is LDF. So again, you have to make these comparisons. If they're both the same, go by whichever one is bigger, which means the higher molar mass. So to kind of finish these up, and again, I like to draw these out. In this case, this is actually methanol, and then this is back to formaldehyde. So formaldehyde, remember, it has a dipole-dipole. So positive, negative, so. This case right here, this methanol, it has an OH. So whenever you have an OH, you have hydrogen bonding. So this is hydrogen bonding. Hydrogen bond is stronger than dipole-dipole. So this one right here will have the strongest. So they're both polar molecules, but remember now, hydrogen bonding beats just a regular dipole-dipole. So methanol will have the strongest. This case right here, they both have NH2 on there, so they both have hydrogen bonding because of this, but this one has 2 of those, has 2 nitrogens on either end, so this is going to be the strongest right here. So they both have hydrogen bonding. One has 2 hydrogen bonds, one has 1. The one with 2 is going to be stronger with it. So again, when you're making these, draw the Lewis structure out, look for hydrogen bonding, dipole-dipole, and then finally a nonpolar molecule will have the weakest of them all. Ionic trumps all of them. If there was an ionic there, it'd be the strongest of all hydrogen bonding, dipole-dipole, and London dispersion.